Hi, everyone. This is our group's final presentation on our data analysis studying the San Diego Airbnb market. Starting with some context, San Diego had a surge of visitors in 2023, increasing demand for accommodations in the area and leading into more investment in the local Airbnb market. New regulations were also implemented in May 2023 regarding Airbnb licenses for short-term rentals. These changes highlight the dynamic nature of the San Diego Airbnb market and shows the need for Airbnb and hosts to adapt to evolving demands. So based on this information, we formed our research question. How do Airbnb listing details, specifically the summary, house quality, and host performance, influence its corresponding review score for Airbnbs in San Diego in 2019?
To begin our data cleaning, we filtered the data frame to include 7 out of 76 columns that best help our research. And we start looking for null values. Significantly, we find 120 entries that have a null rating score, but non-zero total number of reviews. We speculate this trend is due to remove reviews that leave their impact on the review count. We also generate a missingness matrix for the rest of the columns and find that missingness is random, so we drop all entries with the null values. Furthermore, we identify the number of reviews column as a confounder to review score, so we normalize it and remove the influence of outliers. Lastly, to clean our description column, we remove punctuation and transform text to lowercase.
For our EDA analysis, we first looked at the distributions of review scores. We learned that the score is left-skewed, and we decided to compare the trend of our selected features between low-rating Airbnb and high-rating Airbnbs. Thus, we split the dataset into 3 small sections based on the quartile values, and then we continue our analysis and plotting using these 4 datasets. In the first part of our EDA, we examine if there is a relationship between the descriptions of an Airbnb listing and its review score. We use TF-IDF to extract the top 50 most unique words in the dataset, then compare the results we get from the low quartile dataset and high quartile dataset. From these bar plots, we can infer that upper quartile data descriptions are standing out because they make more neighborhood and in-home amenities clear. Next, we evaluate whether host performance will affect the rating from 2 perspectives: superhost status and host response time. By comparing the distributions of superhost status in low quartile and high quartile datasets, we found that high-rating Airbnbs are more likely to be hosted by superhosts. Then we evaluate the host response time versus review score. In our dataset, the host response time has 4 categories, and we plotted the percentage of host response time categories in each quartile. From the graph, we observed that there is a similar trend across 3 quartile datasets, and the response time might not be a determining factors in influencing review scores. Next, we evaluate the relationship between the size of the property and its review score. We first use a correlation matrix. The result shows that there's only a weak correlation between numbers of bathroom, and review scores. We further our analysis by plotting the linear regression line for these 3 columns. In the plots, the linear regression line does not show an increase or decrease within each grouping of properties or across different groups of properties. So we conclude that there's no statistically significant relationship between the size of the property and its review score.
We began our external analysis by conducting multivariable regression models for each of our key variables. For the correlation between superhost status and rating scores, we found the coefficient for the hosted superhost variable to be 3.85, and this is statistically significant with a p-value of 0.000. This means that being a superhost is associated with a significant increase in the review scores rating by approximately 3.85 points compared to non-superhosts. For the correlation between number of beds, bedrooms, and rating scores, the coefficient for the number of beds and bedrooms is negative, indicating that for each additional bed or bedroom, we expect a decrease in the review scores rating. These coefficients are statistically significant as suggested by their p-values, which are under 0.05. However, these negative correlations are not significant as less than 1% of the results are explained by this correlation.
Ultimately, our findings provide actionable insights for hosts to be able to improve guest experience and forecast the popularity of future listings. Some limitations to our work include only looking at 3 features of the dataset, but many more factors can have an influence in review scores, and also limiting our research to the San Diego Airbnb market, so the trends that we found may not generalize to the larger population. Thank you.